Hello everyone, our lesson today is about refraction calculations. Firstly, each of you, he should be able to define the word refraction, or he should be able to explain what do you mean by refraction. Refraction is bending the light ray. If you will take a look on this drawing, here what do we have? We have the incident ray. This is the light ray, and here it's bending. But why it's bending? Because the light, when it passes from a medium into another medium or two different mediums, the light ray, it will refract or it will bend. A scientist, his name was Snell, he discovered that there is a link between the two angles, the incident angle and the refracted angle. What this scientist said, he said that these two angles are always in proportion. What's that mean? Let's take a look on these three drawings. Here, the incident angle, it's how much? It's 15 degrees. And the refracted angle here, it's 10. He said these two angles are always in proportion. What's that mean? If this one, it will increase, also this one, it will increase. Now, here it was 15 and here it was 10. So, he said that sine incident angle over sine refraction angle, it's always constant. Now, the sine of 15 over sine of 10, it's equal to 1.5. But if this angle will increase, 15, now it's 45, also this one, it will increase. It was 10, now it's 28. Now, if we want to find the proportion of these two, sine 45 degrees over sine of 28, also we will see it's equal to 1.5. Again, 45, here it becomes 60. 28, it's 35. Again, we will see, we will get, if we will calculate it, we will see they have the same proportion. Okay, so this, what do we call this? We call it what? Snell's law. So Snell's law, it's what? Snell's law, it's that an increase in the angle of incidence produces an increase in the angle of refraction. Or also Snell's law, you will say the sines of incident angle and refracted angle are always in proportion. Now, refractive index. Refractive index we explained in the previous lessons. Refractive index, we said it's the ratio between the speed of light in vacuum to the speed of light in a medium or specific medium. This medium, it could be, for example, glass, it could be water, it could be acrylic. Okay, to find the refractive index of angles, we can use this equation. This equation, it says refractive index, it's equal to sine of incident angle over the sign of refracted angle. Let's take an example. The example here, it says light in air strikes water at an angle of incidence of 45. So the incidence angle is 45. If the refractive index of water is 1.33, what is the angle of refraction? So how we can solve it? We will use this formula. Again, we will write the formula. We will replace the words with numbers and we will solve it. Applying the above equation, now the refractive index, how much it is? It's given, it's 1.33, equals to the sine of incidence angle. It's how much? It's 45 degrees over the sine of refracted angle. Refracted angle, we want to find it or to calculate it. Now, by rearranging it, doing the calculations, we will get this number. Sine of refracted angle, it's equal to 0.532. If we will convert this number 0.532 into an angle, we will get this angle. So the answer now is 32 degrees. Then calculating the critical angle. Here, when it comes to critical angle, we said, what do you mean by critical angle? It's the angle at which the light cannot refract anymore, but it will reflect totally. Okay, this we call it total internal reflection. Okay, now explanation. When the angle of incidence is greater than the critical angle, there is no refracted ray. All the light is what is reflected. So there is a total internal reflection. To find or to calculate the critical angle, we will use this formula. This is the main formula. This formula, it's what? It's sine C. Sine C, it's what? It's the angle of refraction, equals to 1. This one, it's what? It's the sine of 90. Okay? Here we can get these numbers, or we can get this formula from this drawing. Here for this drawing, what do we have? We have this, it's the light ray, and here it refracts. So this angle with the normal, this angle is 90. Okay, so refractive index equals to sine 90 over sine C. Now, if we know that sine 90, it's always equal to what? To 1. Okay, now this one we got from where? From this 90. In critical angle, always we will have the right angle, or we will have the 90 degrees. Now, over n. What's n? N, it's the refractive index. The refractive index, it will be given, usually it will be given in the question. Now, let's solve the questions. Question number 1. Question number 1, it says, the refractive index of water is 1.33. Calculate the angle of refraction if light in air strikes water at an angle of incidence of 24 and 53. Here, if you look at the question, if you will focus on the information that they gave us, the information are, firstly, we have the refractive index and we have the incidence angle. What they want from us, they want us to find the angle of refraction. So we have this formula, the main formula, refractive index equals to sine I, which is sine of incidence angle, over sine R, which is equal to sine of refraction angle. Now, we will just replace the words with numbers. If refractive index is equal to 1.33, as it's given in the question, now equals to sine I, or sine of incidence angle. Here it's given 24 degrees over sine R, the angle that we want to find it. Now, by rearranging the formula, we will get this. Sine R, it's equal to sine 24 degrees over 1.33. By using calculator, you can find that sine 24 degrees it's equal to 0.406 over 1.33. If you will divide these two numbers, you will get 0.305. Now, again by using calculator, now you will convert this number into a degree. So, by using the calculator, you will find that 0.305 it's equal to 17.8. So, when the incidence angle it's 24, the refraction angle it will be 17.8. So this was the answer for A. Your task is to do B. How you will solve B? You will follow the same steps. You will just need to replace the sine 24 with sine 53. Again, by using calculator, you will just repeat the steps and you will get the answer. Question number 2. Question number 2. A transparent material has a refractive index of 2. A. Calculate the critical angle. These kind of questions are so easy because once you will hear or once you will see this word critical or these two words critical angle, calculate critical angle, directly you will write this equation. This equation you should memorize it. Sine C equals to 1 over n. Sine C, it's what? It's the critical angle, equals to 1, it's from the formula, over n. N, what do you mean by n here? We mean by it the refractive index. So if 1 over 2, so sine C it's equal to 0.5. By converting 0.5 into angles, we will see that 0.5 is equal to 30 degrees. B. If the refractive index were less than 2, would the critical angle be greater or less than before? Here, the question says, if this refractive index, this number 2, if it was less, what do you think? What will happen to this angle? Will it be greater or less? of course, it will be greater. You can just prove it that mathematically. For example, instead of 2, let's say you will use a smaller number, for example, 1. So if you replace this 2 by 1, so your formula it will be, or your equation will be as 1 over 1. 1 over 1, it's equal to 1. And sine of 1, it's 90 degrees. Question number 3. Question number 3, it says, diamond has a refractive index of 2.42. The speed of light in vacuum or in air is 300,000 kilometers per second. Calculate A. The speed of light in diamond. This also we have one main formula. If you can see here, you have the speed of light in vacuum, you have refractive index, you need to find the speed of light in diamond or in a medium. So just what you need to do, you will write the formula. The formula, it says refractive index equals to speed of light in vacuum over speed of light in medium. Here, what is the medium? It's diamond. So we will replace, second step, we will replace the words with numbers. Refractive index, it's what? It's 2.42. Then equals to speed of light, as it's given, it's 300,000 over speed of light in medium, in diamond. We want to find it. By rearranging the equation, you will have 300,000 over 2.42. Now, speed of light in diamond, it's equal to 124,000 kilometers per second. B. Find the critical angle. Again, critical angle, we said once you will hear these two words, critical angle, directly what you will do, you will use this formula. Sine C equals to 1 over n. Sine C equals to 1 over n, and it's what? It's the refractive index, which is 2.42. Now, 1 over 2.42, the answer will be 0.413. The sine of 0.413, it's equal to 24.40 degrees. So that was everything for this lesson. I hope everything was clear. Your task for this lesson is to solve the questions on the workbook, and by the end of this lesson, please watch the video, write a comment, and if you still have any questions, concerns, please don't hesitate to text me. Thank you and have a good day.